Good afternoon, everyone. So, what we were discussing was about, when we are looking at, let's say, reserve estimate, how do we assign some of these probability values? So, this is what we are going to discuss a bit today, more in terms of reserve calculations. Okay, a little bit more details. Okay, now you know that what you have is in reserve calculation is area times thickness times porosity times 1 minus SW, which is hydrocarbon saturation, right? And so let us first try to look at this thickness. Okay. Many times, what you also hear or you also see is total thickness multiplied by net to gross ratio, right? Gross thickness multiplied by some N by G, net to gross ratio. Okay. Now, let us try to understand what this is. Okay. Now, let us say if you look at this particular log, typically if you look at this gamma ray log, what you see is there is a shale formation on the top, which is more like, maybe up to here, because, if you were to put a formation boundary, this is where you are going to put formation boundary, right? At 13700, right? That is where you are going to probably put your formation boundary on the top, and at the base, probably you are going to put it somewhere around this. Okay. Okay. So that is what it's likely that it will be put in the formation boundary for sand. Now, if you look at this entire thickness, which is from 13,700 to almost like 13,975. Okay. So how much is this? 275 probably feet. Okay. It's not given. Of course, it should be feet. Okay. So this is like 275 feet thick formation at this location. Now, now if you look at, so so this formation, which is 275 feet thick, that probably can be even on a seismic that can be mapped. Okay. Because seismic resolution, you remember, it is like 30 feet, 20 feet, or more than 20, 30 feet thick. So if you look at this entire formation, 275 feet, so at this well, that's fine. At another location, you can have these gross thicknesses that you can pick. Now, the thing is, not the entire this formation has this sand which is contributing to your reservoir. not the entire section. How much it has is only these, some of these sands, which is like, put it here. Okay, these are some of the sands which is contributing to this, reservoir. Okay. So, and you remember how you do this one? You take this, shell line and sand line, and halfway between the two, and then you wait a minute. Oh, thank you, thank you. Class चल रहा था. कुछ और urgent चीज है क्या? मैं साइन कर दूँ अभी. अच्छा नहीं, तो मुझे क्या करना है? साइन कर देना है. अच्छा ठीक है, ये बात है. So if you look at this, what you are seeing is only these are the sands which are contributing to this. Okay. And so here you can see here it's net. Net is here 10, 15, 23, 16, 14, 18. All these thicknesses marked here. Okay. So how much is this? 10, 15, 25. कितना हुआ? जल्दी से बताओ तो. 48, 30, 78, 88, 96, 5, 101, 121, 121, and 123, 133, 140, 140, 149, 150, 161, 168. 168, okay? So out of 275, you have 168 feet as your sand, which is contributing, divided by 275, that is what? So this is net to gross ratio, okay? You can take, even if you do not know, okay, in the area, in all the wells, but if you have just one well, from that, you take this, okay, and you can use this net to gross to other locations in the same area, okay. Okay. So this is what you can do. So gross thickness, and that is 275, and net to gross is 168 over 275. That is net to gross ratio. That is what it is called. Or simply, if you want to use this for one well, you can simply use this H as 168 feet thick. Okay. So now, if you look at this this well, and here porosity number is given, so you can take average of this porosity, and that average you can do it like thickness weighted average if you want. Okay, so porosity and then also hydrocarbon saturation you can use. Okay. Now let's say this is, you are looking at a section view. This is a very simplified view, okay? Section view. Okay? Now, if you are looking at a section view, and let's say you have these two sands, which is separated by a shale, okay, and well one, as you can see that here is well one, which is showing you gamma ray and resistivity. Of course, this is that shale high gamma ray streak that is showing up. And if you look at well 2, you have sand throughout, but only above this OWC, that is oil water contact, what you have is that is your hydrocarbon in it. Okay. So when you are calculating, okay, you remember you are calculating hydrocarbon pore volume. This is most important. Okay? Hydrocarbon pore volume. Okay. Now, what about area? How do you calculate this? Now let us say that you have in a section view, okay, or a cross section. This is your depth profile here. You can see depth and OWC, that is oil water contact. So what you basically do is you make contours, okay, like you do contour mapping, okay. So contours at equal interval, okay, and you map this up to OWC, okay, up to OWC, and then you can then again you can use this to calculate area. Okay. So using contour, you can map out what is the area for each thickness. Okay, for each thickness. Okay. Now let's say in an area, let's say you have this contour map, this one, okay, let's say you have this first one as a contour map, which is a structure map, okay. Now in this structure map, you also, now let's say you have this in this area, okay, the sand which is filled in a channel, okay, only the channel filled sand is your reservoir, okay. So if you have channel filled sediment, you can make this channel fill here, like in the second one. You can see that this is the maximum depth, that is 20 feet thick sand in here, okay, and on the side you have zeros, right? So this is your channel. This entire thing is a channel, right? Channel filled sand, okay, and a structure contour is shown here, okay, in the first one, okay, that is your structure contour, and the second one is showing only the channel which is filled with sand, okay. So which in turn gives you, if you take the intersection of these structure map as well as this sand map, okay, what you are getting is this number 3, okay, where you have OWC as the boundary here, okay, and then this is your the edge of your channel, okay, and you have 20 feet thick sand at the center. So this is your sand which is contributing to your production, okay. So this is area and thickness both combined, right? Okay. So if you plot this thickness and area here, the shaded region, that is thickness and area multiplication, right? That shaded region is your net oil sand volume, okay? Net oil sand volume, okay? Okay, are you guys getting this? समझ में आ रहा है? No? Okay. Now let's say I'm trying to simplify now. Let's say you have a structure map of a formation. Okay, this is your structure map of a formation. Okay, in a section view. Okay, let's say formation A. That is a formation name. Okay, formation. Now this entire formation may not be productive. Now let's say only there is a channel sand in this formation which is productive. Okay, maybe I should use some different color. So let's say there is only a channel fill sand that is only productive. Okay. Other parts here are shales. Okay. So let's say in this formation, on this here it's shale, and here you have sand. Okay. Now, how to map this sand? How to get the volume of this? Okay. That is what is shown. So you can build your structure map by mapping formation top. Okay, you can build your structure map by mapping formation top, and then from there you can take this, overlay your sand map, this channel sand, okay, on top of it, okay, and so what you basically get is let me take another color. Only this as your volume. केवल यही sand जो है, it is going to take, it is going to contain this hydrocarbon, right? And so this is what you are going to map this out, that how much, let's say, 20 feet, 20 meter thickness, what is the area? So 20 meter thickness is which one? This one. 20 meter thickness is this one. So first you are going to map out 20 meter thickness, how much is the area. Then you are going to map out 10 meters Okay. How much is the area for 10 meter thickness? And then for 0. So that way you can, so let's say 20 meter, you got this one, 10 meter, you got this one, 0, you got this one, and so then you can make this shaded region. That is what it's going to give you volume of your channel sand confined to that particular structure. Is this clear now? Okay. So, so that way you are going to get area and thickness. And of course, let's say if you know some average porosity, you can do that, and average saturation, hydrocarbon saturation, you can multiply that to get hydrocarbon per volume. Okay. Now, once you have understood this, let's move on. Now, what we are going to learn a little bit about probabilistic distribution. Okay. So you know all these things. Okay. I don't need to teach you a lot in this one. You already. So if you have, let's say, discrete values, and if it plots like this, okay, on the top, you can make it a continuous something expressed like this. Okay. And yeah. You remember we were talking about P10, P90, P50. So let's try to understand that one a little bit carefully. Here, if you have, let's say, probability distribution function as this one, okay. So the curve below, it's what is called cumulative probability. And cumulative probability in reversed cumulative probability, okay, reversed one. This plot is reversed, okay. The one you remember we were doing this in Monte Carlo simulation, okay. So when we said P90, P90 was the lowest case, okay. And P10 was the highest case, and P50 in between, right? We'll come back to that one once again, but before that, let's try to understand this one. For any variable, that means area or net to gross or porosity, you can assign some distribution curve, okay. And this is what you also had available in Monte Carlo, this crystal ball simulation, right? Crystal ball software. You could choose these different probability distribution functions, right? So this is called uniform. Then you have triangular symmetric or triangular skewed or irregular distribution. Okay. Now let us try to understand how to assign some of these distributions. Okay. Now let us say that you have this porosity curve for your sand, and so if you are asked what kind of porosity distribution that is, how will you do that? Amit?
Yes, sir.
कैसे करोगे? अगर मान लो कि एक सैंड का जो है तुम्हारा पोरोसिटी का इस तरह का कर्व है, ठीक है? Let's say you have drilled a well, and in that sand, this is your porosity curve. And then you are going to take this porosity distribution to the entire area. Okay. So how will you assign porosity distribution in this case?
So for distribution, I will pick maximum value and minimum value, and then I will try to normalize the curve.
Okay.
So that it gets smooth. And then,
okay. So basically, what you are saying is you are going to assume that it's a normal distribution, right?
yes, sir.
Okay. But what basically you should do is, instead of doing that, basically you plot porosity histogram. Okay.
Yes, sir.
Okay. And then you fit a curve through that. Okay. Okay. So this is how you are going to, though it appears irregular, but still you can, if you want to have normal distribution for this one, okay, you can calculate mean and a standard deviation from this, and then you can say, well, I'm going to fit a normal distribution to this. Because for normal distribution, what do you need? You need mean and standard deviation. Okay.
Yes, sir.
Now let's say you got permeability. For production, of course, you need permeability, right? चंद्रहास, इसके लिए किस तरह का परमिबिलिटी डिस्ट्रीब्यूशन अप्लाई करोगे?
सर इसमें भी पहले हिस्टोग्राम जैसे बना के देखते हैं कि इसका कितना फ्रीक्वेंसी है.
So if you plot this on a histogram, this is how it's going to look like. Okay? And of course, it's not symmetrical. Probably you are going to use some kind of log normal distribution. Okay. So for normal distribution, as I just said, it's not that difficult. Okay. If you have a standard deviation and a mean, okay, you can have your normal distribution. Very simple formulation that you know of. Oh, so I have a question. Okay, that's fine. Okay, so the numbers on a die are 1, 2, 3, 4, 5, 6. What is the mean of that distribution and the variance? क्या होगा? Think about it. Now, if you have a uniform distribution, for uniform distribution, you have mean and variance. Okay. You have A and B, so that is mean is A plus B by 2, and this is your variance here, B minus A divided by 12. Okay. If you have a triangular distribution, then this is your mean and variance for triangular distribution. नॉर्मल डिस्ट्रीब्यूशन के लोग तो देख ही लिया है ना. Now, many times, okay, particularly when you are looking at permeability, okay, it's very difficult to assign values for permeability or any distribution. But when you are looking at this particular data or this particular plot, what you find is that tentatively there is some kind of relationship, tentatively, and that relationship is किस तरह का है, किस तरह का है. प्रदर्शन Okay, so as porosity increases, permeability increases. Okay, that's kind of okay. Anybody else want to say anything? Looks linear for mouth bars. And channels and के लिए नहीं दिख रहा है क्या कुछ? ये linear है. Okay. अभी मैंने थोड़ी देर पहले बोला था कि जो है परमेबिलिटी जो था उसके लिए हमने कहा था कि ठीक है, looks like it's a log normal distribution. Okay, so if porosity, your porosity is linearly, okay, if your porosity is normally distributed, then your permeability is what? Then your permeability is log normal distribution. Okay, ठीक है, क्योंकि देखो प्लॉट जो है वो लॉगरिथमिक है परमेबिलिटी का, हाँ, लॉग नॉर्मल, ठीक है. So you can use this, and typically for for clastic reservoirs you use this. Okay, now let us see if I have this. So mouth bar porosity is plotted here. Okay, so for mouth bar porosity again, here mean is 16.6 and the standard deviation is 4.7, and the and then there is a curve fit to it. This is a normal distribution. Though it looks like it's a bit skewed, okay, but you know, for practical purposes, you can use this as your a normal distribution. You want to fit this curve through that. Okay. Channel porosity, again, mean is 19.8 and standard deviation is 4. And so again, you can use this normal distribution curve for this purpose, okay? And then what you can do is, you can then make your permeability distribution as well, okay? So you can see this is log normal because here you have logarithmic, okay? Log normal distribution, okay? And channel bar distribution is very much skewed. Okay, so this is what you do is whether your data is normally distributed or log normally distributed, what its mean and the standard error, all these things you can do. And then this triangular distribution is basically, you know, it's based on perception, okay? Mean, max, most likely. Okay? Mean, max, and most likely. And with these three numbers, you can create your triangular distribution. Other distribution can be some of these what you call catastrophic distribution, negatively skewed, compressed. Compressed, maybe, you know, this could be, yeah, see this facility constrained production. If your facility has limited, limited capacity, so it is constrained, right? And so you can use this. So what you do for distribution, gather the data first, okay? Distribution must be at least as spread as the data, okay? Whatever distribution curve you try to fit, okay, it should have those characters, okay? Then evaluate the data, remember the physics of the process, okay? Estimate the most reasonable distribution, calculate what is important, reconsider the distribution assigned to most important parameters. Okay, so if you find something, you know, that some distribution may have to be assigned differently, you do that. Okay. Oh, so I have another. This is just for fun. I had on probability distribution. Let us see if you can answer this one. Assumption, medical test. Assumption 1: a test for a disease is 98% accurate. That is, if you have the disease, the test will be positive 98% of the time, and if you don't have the disease, the test will be negative 98% of the time, right? Assumption 2: 0.5%, 1 in 200 people have the disease. You have taken the test at a routine medical checkup, and your doctor somebody informs you that you have tested positive. How depressed would you be? ये सब probability की बात now let's come back to this cumulative probability thing. Okay. Let me see, there are two things. One is, I'll come back to this later as well, but right now let me give you this concept here. One is P90, P50, and P10. Then also many times this is what is reported, okay? And then also you have P85, P50, and P15, okay? These are two different nomenclature that are followed in case of probabilistic reporting of reserves, okay? So when we say either P90 or P85, what does that mean? That there is 85% chance that you will have this P90 or P85 reserves or higher. Okay, look at this one. I go back to that slide once again. I'm flipping this slide. I do not know if that it's taking long time for this to appear on your screen. Which slide do you see? A probability density function. Do you see that? And expectation curve. Okay. Now, so when we say P10 or P50 or P90 or P85, look at this. This here at the bottom. Probability of X more than or equal to X1. Okay. So when we say P50, that means chance of getting that, chance of getting that number, 50%. What is that? Let me say that again. P50 reserve is when probability of occurrence of P50 reserve is okay. Okay, so now let me go back to this slide once again. Yes, Raj. Hello, yes, Raj.
Yes, sir.
Okay, so what is this P90, P50, and P10?
Sir, P90 means there is a 90% chance that we will have P90 reserves or higher than that.
P90 reserves or
Reserve or higher than that reserve percentage of chance.
okay, so that means that is the low case. Okay,
Yes, sir.
that means there is 90% chance that you will have more than this reserve. Okay, ठीक है?
Yes, sir.
If let's say this reserve is R1, okay, you have here of course 85. Okay, so there is a 85% chance that you will have reserves more than R1. Okay, ठीक है?
Yes, sir.
And when you have high case, that is here it's P15, or in many cases it's P10. So that means you have, फिर से इसको बोलो क्या होगा?
We
That
have
you,
minimum 50%
no,
chance
no,
to
no.
have.
You have 15% chance that you will have more than this reserve. Okay, more than this, or let's say RH, high case. ठीक है? There is a 15% chance that you will have more than RH. Okay? समझ में आया?
Yes, sir.
इसमें तुम लोग बार बार गलती करते हो, so let me. हाँ, निखिल.
Yes, sir.
हाँ, बताओ.
Yes.
P85 क्या हुआ?
सर P85 का मतलब ये हुआ सर कि वो जो भी रिजर्व की वैल्यू के करस्पॉन्डिंग हम P85 बता रहे हैं उससे ऊपर हमारे रिजर्व की क्वांटिटी होने की चांसेस 85% है.
ओके, यस, ठीक है.
यस सर.
ओके. अरुणिमा. अरुणिमा. Chandrahas.
Yes, sir.
What is P50?
Yes, sir. P50 मतलब हमारे पास 50% चांस है कि हमारा रिजर्व उस रिजर्व से ज्यादा होगा.
Okay. There is a 50% chance that there is a, okay, the probability of occurrence of reserve more than that, whatever that number is 50%. ठीक है? Okay. So now let me go back to this slide here, which I had skipped earlier. There are 4 curves shown in this cumulative probability plot. Do you all see that? Okay, so now when you have this curve 1, look at this, cumulative probability starts here, यहाँ पर जो है 100% तक है, ठीक है. Even for 2 also you have this, but for 3 and 4 that is not the case. What is the difference between 1, 2 and 3? Who will tell me? Harshvardhan? बहुत लोगों का तो माइक काम नहीं कर रहा है, तो जिसका माइक काम कर रहा है, let me talk to those only. Amir,
Yes, sir.
what is the difference between 1, 2 and 3?
Sir, I think 1 and 2 are complete in themselves, but somewhere 3 is a part of something else. The reserve. So the reserve estimation for 3 is a part of maybe another reservoir, or I don't know how to say that.
Okay, so अभी तो मैं थोड़ा सा बताता हूँ, and then we will continue tomorrow. 1 and 2 is, there is 100% here probability. That means it's already discovery. Okay, this is already discovered. Okay, and therefore there is 100% chance that you will find something, right? Lekin that is not the case for 3 and 4. Okay, so 1 and 2 is typically for development, but there is still difference between 1 and 2. Okay, we'll discuss that tomorrow. And then 3 and 4 are for exploration. Okay, so development, exploration and appraisal, ये थोड़ा जो है हम लोग कल देखेंगे, हाँ? ठीक है?
Okay, sir. Okay, sir.
Okay. Bye.